Assalamu alaikum. Today we're going to talk about one of the most important topics in machine learning, which is PCA or principal component analysis. So what is this PCA? PCA works on simplifying complexity with dimensionality reduction. So what is this PCA? So before talking about this PCA, I will give an example. Just like suppose we have a data set of 100 people where the features are their height, weight and size, etc. So here in a data set there are some features which are similar in nature and some are not. So what the PCA actually does, it removes the similar features and it only considers the most important features. So you can see that reduce dimension while retaining variance. So PCA reduces the dimension as it removes the similar or redundant features. So it can find axis maximizing variance, simply large dataset for easier modeling. So it simplifies the large datasets for easier modeling as it reduces the dimension. So in this picture we can see that this is in first picture, it is a picture of 3D scatter plot of a dataset, but in 2D that is in better visualization. So we can see that the reduction or when we reduce the dimension, the visualization or the analyzation is easier in nature. So why do we need PCA? So before understanding why do we need PCA, we have to talk about what are the issues in higher dimension. Actually, the visualization and the overfitting are the issues in higher dimension. And we know that the PCA can reduce the dimension. So what are the benefits in PCA or using the PCA? First of all, remove redundant feature. We have already talked that the PCA can remove the redundant features. It can reduce complexity as it reduces the dimension, and we know that in lower dimension the complexity is lower. Also in lower dimension the algorithms can be speedy. Also they will give the better visualization. So we can see a picture here that in one dimension the dataset is in a serial form. So this is easy to visualize and easy to analyze. But in 2D this data is little bit complex to analyze or visualize. But in 3D also it's much more complex than the previous. So now we'll talk about how does PCA work. So first of all, the standardize of the data, then compute the covariance matrix, after that finding eigenvector or eigenvalues, after that selecting top components, after that transform the data. So we can see it as a flow chart here. Performing standardization of the initial set of continuous values, after that find the covariance matrix, after that we will find out the eigenvalues or eigenvectors, after that we will figure out which PCA to return, and after all in finally we will replot the data on our original axis. So what are the example of PCA? Scenario 3D data reduced to 2D, this is an example. After several examples are given here. And finally, what are the applications of PCA? So we can apply PCA into image compression, also we can apply PCA in noise reduction, also we can apply the PCA in data visualization onto the 2D or 3D plots. So that's all about PCA in machine learning. Thank you everyone.